So first of all, introduction to IPCOS. We are a company which provides expert services for plant optimization and control. There are about 65 employees in IPCOS. There you see a photograph that was taken a few years ago on a company team building event, and the photograph at the bottom there is the city of Leuven, city center, which is where our head office is. We have offices around the world. This next slide shows you our main offices, which are in Cambridge, in the UK, Boxtel in the Netherlands, Leuven in Belgium, Chandigarh in India, and Abu Dhabi. And we also have some partners that are spread around in different parts of the world. We provide sort of vendor-neutral services for studies, audits, process control and automation type things, feasibility benefit studies for advanced process control, PID tuning and base layer optimization. And obviously our main focus is in advanced process control in implementation, and of course APC maintenance, which is the subject of today's webinar. We also provide training for advanced process control as well as PID tuning courses, and you can find obviously all the details on our website at ipcos.com. A list of our customers. These are just some logos there, and this is really a short list. You will recognize some of them, and probably some of them are you gentlemen and ladies are attending the webinar today. So let's talk about APC maintenance. Typical issues. So really there's many forms in how you come across problems in APC maintenance. You hear things like you walk into a control room and you hear somebody say the controller is not maximizing feed today, or they will say something like the feedstock and products have changed and therefore my controller's behavior is different. You might hear things like I get frequent alarms on skin temperature. We get the product draw valve is cycling, the quality goes off spec during the day. And as a control engineer and as the custodian of the APC system, you need to decipher these comments and get to the bottom of what this really means. Because quite often it is the operators who are operating the plant and the APC system who are really making these sorts of comments. And you need to make sure that we are fully understanding what this means in terms of the APC performance. Some other typical types of things, well, you might hear something like the controller has been switched off since the plant was revamped. So that's a telltale sign of something that has changed. We have a number of new operators. The controller is now turned off. That's a fairly common complaint. APC engineer got promoted or he got moved on to a different job, or he's left the company and now the controller is turned off frequently. The operating strategy of the plant has changed, and the controller solution is now inconsistent with the strategy. This is also fairly common. So really there's a host of things that you will hear as the plant control engineer and as the operator and control engineer. You really need to make sure that you understand what is happening that is causing these comments to come through. So we have to look and understand what is coming from beyond these comments. Now this is a slide that a lot of you have probably seen. It's really looking at lost benefits after the APC system has been commissioned. So you will see that initially the plant, the APC controller on the plant gets commissioned and it's working fairly well. you're getting, say, nominally speaking, 100% of the benefits. And over time, and this could be over 6 months, 12 months, 24 months, it really depends on what are the issues that are being faced. The performance of the APC system degrades and really doesn't help in terms of the future performance as well as the benefits. So really you can see that there's some lost benefits here, and these lost benefits are really not what we want. We want to maintain the benefits at a very steady pace so that the future benefits are obtained and they are just as much as what they were at the beginning of the project. Okay, so really this slide emphasizes the importance of APC maintenance and of keeping the benefits at a high level, because you really want to make sure your investment that you made at the beginning is paying off. Now, what do we feel and know? This is kind of like not based on statistics or numbers, but this is based on speaking with several customers. As an APC consulting company, we have obviously engagements with several customers around the world, and also we talk to large companies and the engineers on site. So I wouldn't say this is a definitive statistic, but I would say it is quite probable that greater than half the applications degrade within 12 months of commissioning. I don't think this is an exaggeration, but I think it is a realistic scenario. The other thing I have noticed is that APC maintenance is really treated as a reactive type of activity, not a proactive activity, which is also fairly common. And also there's different attitudes to APC maintenance in different cultures and different refineries or chemical plants, petrochemical plants. And by that I mean, you know, if you're a new adopter, you have a different approach because the technology is new, you're still learning. If you are an adopter of the technology from the sort of 90s or mid-90s, then you have already had a mature technology implementation. The people are aware of it, so you really have a different view towards it. And then the other thing I guess we can say is that the so-called APC engineer is really doing a lot more than just APC maintenance or APC projects. These days there's a lot of pressure on engineers on site, and people are really having to do several activities. So, you know, somebody might be doing an alarm management activity or a mass balance reconciliation project, and APC maintenance gets left behind because people feel, oh well, it's running, it's switched on, and it must be doing something right. Okay, so these are the sort of things that sort of provide a background to what causes sort of issues with maintenance. So let's look at what are the typical troubleshooting scenarios that we might come across, and how do we feel that the controller performance is degrading. So the most obvious one is to say the uptime is reduced. So the controller uptime, which is the amount of percentage of time I guess the controller has been switched on, can easily be monitored. All the different APC technologies can provide this value, so to speak, this number. And if that is reduced, then clearly you know there is a problem, and that's the most common one to look at. Another one to look at is the manipulated variable or the independent variable limits are clamped, and most of the constraints are on the MVs. So this is also a bad sign. When all the limits or most of the limits are on the MVs, it means the controller is not really actively seeking out benefits and generating benefits for your plant. CV limits are violated frequently, so that comment from the operator which says, oh, my skin temperatures are constantly in alarm, it means that something is wrong, and the controller CV limits, which are the values that we want to control within a tight range, are not being met, and we are constantly violating those. So that's also a good telltale sign. And also there's several situations where operators are making changes based on day and night swings in temperature, so that also tells us that, okay, there are some things missing in the controller, maybe the design is not good enough, and that's causing us some problems. Other sorts of things in terms of troubleshooting, diagnostics. We can look at diagnostics in advanced process control systems. There are different technologies have their own sorts of diagnostics, and you can actually look at those diagnostics, and that can give you an idea of, for example, if there's the percentage of the time that the MVs are on limits, the percentage of time CVs are on limits, if there's LP violations, all sorts of things that can be, extracted from the APC system, and that can give you an idea of performance degradation. Another area which is really worth looking at is PID base layer performance degradation. This quite often contributes towards poor APC performance, and this is an area that must be looked at fairly frequently as well to make sure that there's no issues there. And again, there's various ways of doing this. Some companies have PID loop performance monitoring packages in place, and some don't, in which case you can quite easily detect the performance or the bad actors by just looking at PID set point PV outputs and trending them, and certainly the key ones, and making sure that they're working well, the key MVs. Another area worth looking at is comparing the benefits against the benchmark. So if you have that 100% value at the initial commissioning stage, and that 100% benefits could equate to, for example, a certain feed rate in engineering units, that is a metric for your plant, or it could be a dollar value in terms of benefits that were generated from various aspects, such as increased production, better energy usage, and that dollar figure could be, say, $1 million a year, for example. And it's always good to make sure that you compare your current performance against the benchmark, and when that starts degrading, then again you know that there's some issues that are worth looking at. Besides the benchmark in terms of performance, there's also some KPIs, or key performance indicators, that can be created, and these could be things like standard deviations of some variables, or some key performance qualities, maintaining them within a certain limit, or some inferential quality is maintaining those, perhaps compressor speeds, and various other types of variables that can be configured that are important for the plant, so in terms of controlling them reasonably tightly. So there's lots of different things that are available to you as the engineer in order to get a feeling for, how to troubleshoot the degradation. So various areas you can look at. So the next slide I'm going to focus on a little bit is best practices. So what we really want to do, this slide talks a little bit about continuous improvement. So kind of like the opposite of losing benefits. It's really about how can we continuously improve the APC system so we get even more benefits. By the way, this slide is taken from the ARC report in 2008, and I thought it was a good way to tie it in with best practices, because you really cannot get continuous improvement in performance unless you put in place some best practices within the company for the APC maintenance. And really the point of this slide is to say, good companies that are looking at their installed APC systems are constantly striving towards, not just maintaining and sustaining the application and the benefits, but actually improving them and increasing the benefits over time. And this is not blue sky stuff. This is actually things that can happen based on, a set of processes and a set of procedures and methods that you can put in place in your plant. So what are the other best practices we're looking at here? So I've separated this out into sort of technology type best practices, as well as other aspects of best practice which are related to sort of training and people activities. In terms of technology, there are various things that you can look at, such as model errors. And model errors is the difference between the predicted and the actual values that you get out of the APC system. And if there's an error in the model, then because really the plant has changed over time, or perhaps your original model was not good enough, then that will show up in the model error metric, so to speak, which is available in most APC systems. And the uptime is another variable we talked about, so that can give you a very rough feeling for what is the uptime of the controller, but it doesn't really give you a feeling for the health of the controller in terms of how well is it performing. You can also look at MV and CV constraints and look at the percentage of the time certain variables are at a constraint, and that can give you a little bit of a pattern in terms of how that constraint set is moving around. And if there is a certain requirement, such as you always want to maximize feed, or you want to maximize a certain product, then you can pick that up very quickly by looking at the percentage of the time that constraint is active. And if it's not active very frequently, in terms of on the high limit or low limit, whichever way you've set that up, then that means that you really need to try and change look at the reasons for that. You can also do some trending. I mentioned that earlier on PID loops. So if you have base layer issues, you can trend set point PV outputs and see if there's any problems with that particular PID loop, and see if you can improve that performance by doing some tuning. And of course, if you have a closed loop performance monitoring system, PID loop monitoring system, then you can use that to provide you with some diagnostics on PID loop performance and address those issues as and when required. The stability of the LP solution is also extremely important, because that then drives the performance of the controller in terms of maximizing benefits or the defined strategy. And if the LP solution is not stable, and this can happen because of various reasons, mathematical reasons, then you need to address that. And you can see the symptom of this when the LP solution is kind of flipping, so to speak. It's moving not in a stable region, but it moves from one solution to another. And again, the technology, the APC technology that you have should be able to identify the LP solution, the typical LP solution quite easily. It's also quite important to look at the inferential calculation. So if you have several variables that are available in as quality measurements in the lab, but those measurements are not frequent. They are only, say, once every day or once every 8 hours. Then in the APC system, what we can do is build an inferential calculation, and that inferential calculation will give us a higher frequency measurement of that particular value by us calculating it on a minute by minute basis. Okay, so that we can always do that comparison against the lab and see what is the deviation, and if there is little deviation, then we know our inferential calculation is working well, which also means then our APC system will be performing very well. You can also prepare benefits and baselines for the key performance indicators. It's always good to do that and compare the performance against those metrics. Sometimes as part of the project, when you finish a project, you will have these metrics in place already, and all you need to do is make sure you compare or generate these performance numbers on a regular basis and compare them against the benefits. Okay, so that's also quite important. Now, in terms of other best practices, there's some things that I would call routine activities. So as an APC engineer or the custodian of the APC system on site, I would say one of the most important tools actually is to just go and chat with operators and go and speak to them and find out how you can, how is the system working, and is there any issues. Typically, spend 3, 4, 5 minutes, 10 minutes with the operator, and quite frequently you will hear those comments that I pointed out in the first few slides. And those comments are the ones that you will need to kind of decipher and get to the bottom of. Very important to do that and get a feeling on what's going on directly from the operations people. And I know there's several formal meetings, etc., that are available in most operating plants, and those meetings, do also provide an insight as to what's going on with the APC system. But I think having worked this field for over 23, 24 years, I really feel that the importance of having a chat with the operators is on the top of my list in terms of really getting to the bottom of finding out the problems and then troubleshooting them. Review trends of key variables. So this is also quite important. If you've got a APC controller on a distillation column or something, set up a trend group or something of the key variables, and have a 8-hour trend or a 1-day trend or something that can give you a feeling of how are things moving over time. Is there lots of changes taking place in certain key variables? Are they fairly stable? Do you see some day and night changes? And then you can always ask questions on the basis of what you see in the trends. So if you see a sudden change in the feed rate at night, you can find out from the operators what happened, and they might say, oh, well, there was a disturbance or there was a pump that tripped or something. But it's important to know all of these things, and it's amazing how much information you can pick up from just doing some trends. Check the limits. So, this is, again, one of the biggest reasons why controllers kind of stop operating is because the limits get clamped. And I think this is an important routine activity where you check the MVCV limits and make sure that they're not gradually getting clamped, and really challenge the people in operations as to why, for example, they have clamped some limits. And by challenge, I mean, discuss with them in the nicest possible way and understand what are the reasons behind it. And quite often you will learn something from that activity of having spoken to them, because they might say, well, this CV was not was getting violated all the time, so they had to clamp the limits on the MVs in order for that not to happen. which might give you a clue as to perhaps there's a problem with the measurement or there's a problem with the model. So that will then lead you to investigate further and understand the root cause of the problem. Quite often, technologies can provide a on-off switch of CVs and MVs, control variables, manipulated variables, and if some of those have been switched off, then it's quite important as part of the routine activity to find out why they are off and address those instrument issues on an urgent basis. Because if those things get left, then really that particular variable might stay switched off for a long period of time, and that's not what you want, certainly if it is an important variable. Look at the consistency of the controller strategy with the production targets. So if you have your production meeting every morning, and in that meeting people are saying, well, today we are processing 300 tons an hour of feed and our products are such and such, make sure the controller strategy is actually achieving what the production people are asking for. It's a simple activity, but quite often it will lead you to perhaps making adjustments or making changes as required in the controller. Now, we can also come to some monthly, quarterly activities at a slightly smaller frequency. You can check performance against baseline. So you could, for example, produce a quarterly report or a monthly report that can go to management in terms of those benefits in dollars or feed rates or whatever are the key performance indicators that you've chosen for your plant. Discuss the changes in operations strategy with your planning people or whoever are the relevant people making those decisions on the plant. So these could be things like, while we are now maximizing gasoline production rather than diesel production, or we are looking at producing more propylene versus cracking harder, for example, on a refinery type setting, or in chemical plants and gas plants, it could be different strategies as well. It doesn't hurt to check. Quite often these things don't change very much and very frequently. In certain business segments they might not change, in certain business segments they might change quite a lot. So it's worth checking for yourself on your particular plant how and if there are any changes. You must plan a revamp of the controller when the plant is being revamped. So if you know that the change, there's some new distillation column trays being put in, make sure you plan that in advance. So if you know there's an activity on a particular plant in a month's time, make sure you get the list of changes that are being made on the plant, and quite often you can get those from the plant turnaround project manager, and you will be able to see what are those changes, and you can then determine whether those changes will impact the controller in any way, and you should make those changes well before or plan making those changes soon after the plant has been revamped, so that your controller is again pushing against the maximum benefits. In some cases you might find that the changes are very small, but it still doesn't hurt to check. So it's really an exercise that you must do. You must also look at discussing and planning proactive improvements. That slide you saw where you are actually increasing benefits rather than just maintaining benefits at the level of when the controller was commissioned, is really all about improvements. So they could be that you are able to push harder against certain constraints. Maybe there's an alarm that is holding back production, or there's an alarm limit that has been set that is holding back production. It's worth challenging the people and asking them, can that alarm be moved, for example, by a couple of degrees? And quite often that might involve a discussion with various people in maintenance, and if it's an important alarm, and check if it can be moved, and if not, then perhaps justify the reasons why it should be moved. Maybe by moving it, it will generate significant improvements in benefits, and then you can prepare those sorts of cases and present to your management for further improving and enhancing the APC system. So this is also an important activity, and I think this is something that fits very nicely in a quarterly type of review. Check the inferential predictions against lab values. We discussed this already. This is a very easy activity to do, and it will give you a very quick feedback on what the status is of your inferential calculations. And you can very quickly make corrections, and that will give you benefits or improvements very quickly. Evaluate opportunities for new applications. So there might be some things, mundane little plants here and there that perhaps you thought are not really worthy of APC. It's worth looking into those. There could be, for example, a steam or a steam generating plant. It could be a furnace or some sort that is on a small plant. These are all things that are worth looking at. And perhaps you might determine in the short term that the plant is not worth doing APC on, but certainly revisit that on a quarterly basis to see if perhaps the situation has changed. Okay. Now, the next couple of slides are also from ARC, and the reason I put these in, they are really to do with the aging workforce. These slides relate to the US in terms of numbers, but I think they are reasonably representative, certainly in Europe and perhaps a little bit less in other parts of the world. The slide on the top here shows the number of people and the years and the ages. So if you look at in 2010, the number of people over 65 years of age were around 40 million in the US, and by 2020 they're going to be about 50 plus million, and in 2030 there's 70 million. Well, why is this important? Because this just tells you the number of people who are going to be retiring, right? A different way of looking at the same problem is this graph here, which shows the number of people from 35 to 44. That's the one in blue. The one in red is the number of people from 45 to 54, and the one in green is the number of people from 55 to 64. So this is the demographic from 2000 to 2010. So over 10 years, the number of people from 35 to 44 has dropped by 10%, while the number of people from 55 to 64 has increased by 52%. Okay? So why is this important? It's important because of training and technology transfer. I think we are all aware that it's from an engineering perspective, it's kind of hard to find people, and certainly experienced people. And on the other hand, you have a number of people that are at the age where they are retiring, and really all that knowledge and experience is kind of evaporating as they leave the company. So training and technology transfer in all areas is important, but in the case of APC maintenance, it's also extremely important. We need to make sure that all the stakeholders in the APC world on your particular plant or your site or your asset are trained, and that means operators who are operating the plant and using the APC technology as a tool to operate the plant. They should have a good training They should have the training material available at hand so they can have access to it easily. I would suggest to have a refresher course for operators every 3 months, for example, or every 6 months. The reason for this is you have different levels and of operators. Some of them are very familiar with the technology, some of them are less familiar. And you have to remember the primary purpose of having the operators is to operate the plant, not to operate the APC. So they are spending 90, 95, 99% of the time looking at the plant and the issues, and their attention on APC is very limited. So quite often you will find that their knowledge is over time has eroded a little bit. And as APC engineers, obviously we have a different perspective. That is our focus. But as operators and other stakeholders, that is not their primary job. So you will have erosion of knowledge. So things like, the importance of setting limits, those sorts of things we understand very well, but, you might find other stakeholders perhaps not maintaining that high level of focus on those sorts of issues. So it is our job to make sure that those sorts of trainings are carried out on a regular basis. Engineers should be trained on new features of technology. This is quite obvious, but again, take the time out and make sure you highlight to your management that you should get training in these features. Sometimes it's tempting to just do it on the job, but it's always good to take yourself out of your environment and go to a training course perhaps if you feel that'll help. So make sure you take the time to do these things. I already mentioned something about generating awareness amongst all the stakeholders, and this really comes back to not just training but also generating some sorts of reports that you can share, that can give people a feeling for how well is the APC system doing. And clearly, if you are actively engaged with all the stakeholders and talking to them about improvements, etc., this sort of thing will start happening kind of automatically. Attending conferences, webinars, workshops, presenting papers, these are all very useful things to do because you will learn from other people and what other companies have implemented. You might get ideas for yourself in terms of the sorts of applications you can build, things you can do to improve maintenance. So again, get a wider perspective. And in terms of training, this is an important one. Make sure you train your replacement. I mean, quite often people will get promoted and they move on. Make sure you are training your replacement fairly well and doing a proper handover. So those are the key points I see on technology and training transfer. So in summary, this is last but one slide. I think it's just a couple of slides left here. In summary, APC maintenance, I would say, is an essential activity. It's not a nice to have. It really is an essential activity. I would say TLC is important. Tender loving care, and that means lots of things. Make sure you pay attention to what's happening in the control room, and not just the application itself and what statistics come out, but it's a wider activity than that. Generate awareness and support amongst all stakeholders. That's also a big part of the job, is to generate through all these communications at various levels with all the different stakeholders, to generate the awareness and of the benefits the application is generating, and get all the stakeholders to agree that this is a technology that really needs to be maintained and sustained, and that as the custodian of the APC system, you should be given the right time, training, resources to actually do that. Create a baseline for comparison, clearly important to see where you are, and if you are actually able to improve on the baseline even further. For example, you could create a new baseline as well in the future. Share the success and generate credibility for the applications that you have, and get management support. That's quite important as well. Make sure that people are aware that, of the benefits that are being generated. Even when things are going well, you should be diligent, spend some time, and, have a chat with people and make sure it's not just reactive, but it's proactive. And do not rely on technology only. Technology these days can provide lots of numbers, statistics, all kinds of things, but quite often, going back to my first couple of slides, it is the comments that you will hear in the control room that should make you think immediately. You shouldn't have to rely on just what the technology tells you. I think listening and understanding what the operators, what feedback you're getting is a very good clue as to what steps you should be taking. Okay, so thank you very much for your participation and your time. I appreciate it very much. And a couple of other items. If you'd like a copy of this presentation, please email me at sam.dhaliwal@ipcos.com. If you forget that, if you forget my email address, you can always email us at info@ipcos.com. There's you can visit our website. There's various ways of contacting us. We have lots of old webinars available as well on our IPCOS YouTube channel. So if you just search in Google for IPCOS YouTube, you will see the IPCOS YouTube channel link. Feel free to go there and play back some of the older webinars that we've presented, and those are also there's also information available on our website. Our next webinar will be on the 22nd of March, and it's on tuning cascade loops. So that's all I have. Thank you very much. We've got a few questions that have come up, and if you haven't had a chance to submit your questions, please feel free to submit them now. So the first question we have is, how frequently should the controllers be audited, say internally or externally? I would say it's probably a good idea to audit your controllers, say once every year, once every 12 months, really because you want to know where that baseline is, where your current performance is as compared to your baseline. And also, like I mentioned briefly, there might be a reason for you to adjust the baseline. So, you could have, for example, a major mechanical problem on a plant which severely restricts you from, pushing feed rate to, your normal production requirements, in which case it would be unfair to constantly report that you're running at 80% of the baseline when really the reason is, a mechanical problem that is causing that. So, or you could have the opposite where you've bottlenecked the plant and suddenly you can push more feed or more products, in which case as well you should adjust the baseline upwards. So I would say about every year. We have a question here. How can you attribute model errors to particular MV-CV pairing? I would say that there's the technologies themselves provide quite a lot of information on that in terms of the model error. So once you know the model error is available, the model error for a particular CV, you can look at all the different MVs, and you can look at the predictions from those particular MVs and run them through, say, data that you've got, and you can find out from, for example, 2 of the 3 MVs were not moving, at the time when the model error was high, then you know that the third one is the one responsible for contributing towards the model error. There's also various statistics available in different technologies, but I wouldn't say it's an easy one to decipher. I think you really need to look at the data and understand the models a little bit in detail in order to get that. Can performance metrics for APC be configured in a database is another question. Simple answer is yes. You can look at, these days you can save data for quite a long period of time, and specifically MVCV data, and once you've saved it, you can quite easily extract it and create some metrics of your own, because in reality you don't, if you have a controller with 20 MVs and 50 CVs, you might only have 4 or 5 key metrics, so you don't need hundreds of tags to create those metrics. You can create those metrics from, say, 15, 20, 30 tags. And if it's things like energy consumption, specific energy consumption, or feed rates or production rates or quality targets, you can pick those up quite quickly and generate your own kind of report in, it could even be in Excel, for example. So yes, it can be done, and in fact that can be very useful, because in terms of communicating to all the different stakeholders rather than communicating the metrics that come out of the technology, which can be quite confusing. Another question we have here is, who should be trained and how frequently in order to get the best controller performance? I touched on that a little bit, but I would say the operators or the people operating the controller are extremely important that they are refreshed on the training, and it doesn't have to be a very long training. It could be just the key points. Certainly engineers. I would also say it is worth training other stakeholders, such as operations people, shift controllers and people in planning and those sorts of things. And that is really for them to understand how the technology works and how it drives towards, the targets that are being set, so that when you're working with them to determine new targets, they understand at least the basics of how the technology works. I have another one here. What type of information should be on a management report in order to communicate the benefits? I would say, make it as simple as possible, and make the information such that it relates to the daily planning type of activities that are taking place. So, for example, if you've got on your planning targets, production rates as well as quality targets, etc., make sure those items are addressed in the same way in your report, so that there can be a direct connection between what is on what the management is looking out for, as well as what you are generating from the APC. So I think it's a good idea to keep it simple and short, and also consistent with your operations targets or operational report that you have. How can you detect whether controller performance degradation is due to APC or PID/base layer? I would say this is kind of like finding out the performance of the PID loops or the base layer. So again, if you have some closed loop performance monitoring software, that you can use that, or you can just do some trends. And I guess the way to detect it is to really find out if the PID loops are behaving badly in the first instance. And this again forms part of the daily activity that I mentioned earlier. I think if you stay on top of it, then you don't have to do a massive sort of hunting exercises to figure out which is the bad actor. I think if you do it on a regular basis, you should be able to detect that the bad PID loop fairly easily. I think that's all I have. If there's any other questions, please feel free to send them through the chat window in the next minute or so. If you don't get any more questions, then thank you very much for participating, and please provide us with your feedback on any of the subjects that you'd like to discuss in these webinars. Obviously APC type of subjects or PID related subjects, feel free to give us that feedback. And also if there's obviously any other APC related questions, then feel free to let us know. I see we have no more questions, so we will close here, and thank you very much for attending, and have a good day. Thank you.